So in the last lecture, we saw that we need neural networks to approximate a given policy because we cannot calculate a matrix for infinite into infinite state value pairs, state action pairs. In this lecture, we are going to understand that how does a neural network approximate a policy. So we know that for a neural networks in a neural network we have inputs, we have outputs, and sorry. So we know that in a neural network we have inputs and we have outputs, and these in a neural network we try to maximize a given function. So in a neural network that is used in reinforcement learning, basically the states of that particular environment are usually the input. The input is usually the state, and the output is usually the actions that we can take from that particular state. Either it can directly be the best action that you can take from this state as, or it can also be a distribution, a probability distribution of the best actions. So for example, a1 has the most, has the most probability, a2 has the next highest probability, and a3 has the next highest probability. So yeah, you can use a neural network. You are going to input state or states, and in the output you are going to get the next action you can take, or a probability distribution of the actions that you can take. Now if you are going to follow a greedy approach, then you are always going to take the best action, and if you are following an epsilon greedy approach, you are going to take the best action 80% of the times, and 20% of times you are going to explore the other actions. This we have understood from before. Now I also want to tell you that if the policy directly gives you the best action to take given the state, then it is called a deterministic policy. But instead, if it gives you a probability distributions of the best actions that you can take from that particular state, then it is called stochastic policy. So now we know that we can use a neural network to approximate a given policy. We can take the states and as inputs, and we can output an action or a probability distribution of actions. Now we also know that in neural networks, what we do is that we are actually trying to either minimize a thing or maximize a thing, because we are always looking to optimize. So in reinforcement learning, we work on the notion of gradient ascent. So if we are considering reinforcement learning, then what is the thing that we are always trying to maximize in reinforcement learning? In reinforcement learning, we are always trying to maximize the return of a trajectory. We are always trying to get the maximum return from a given trajectory. So we are going to present our objective function as something that is related to return. So we represent our objective function j of theta, where theta represents the weight of the given neural network, is equal to the expected return for this trajectory. The trajectory is represented by this symbol tau. So this equation reads that the expected return we get for this trajectory tau under the policy pi of theta, where theta represents the weight of the neural network. And what is our goal? Our goal is gradient ascent. We want to maximize this g of theta. When this g of theta is going to be maximized, we will say that the neural network has succeeded in approximating this policy towards its optimal condition. So again, j of theta means that the expected return we get from this trajectory uh, tau, where this trajectory is following this policy pi of theta, and theta represents the weight of the neural network. So if we are trying to minimize or maximize a given objective function, then we need to calculate the gradient of that particular function, and it is represented as gradient of j with respect to parameters theta. So Now if we need to calculate the gradient of an objective function, then we would need to update the weight of the function as well using this gradient. So the gradient ascent formula is represented here. It is analogous to, if you have seen in commonly when we are talking about a loss function in deep learning, we say that if we have a weight w and we want to update this weight, then we are going to take the previous value of this weight, we call it w old, and we normally, because we are trying to minimize the loss, so we subtract instead of adding. We take a learning rate and we multiply it with the gradient of the given function that we are trying to minimize. So in gradient descent we are actually trying to minimize the loss, and in gradient ascent, as used in reinforcement learning, we are trying to maximize the given objective function. So this formula represents the gradient ascent update for this objective function g of theta. So this is how we use neural networks in reinforcement learning, and we have discussed what is the objective function for the particular neural network that we are training, and how the weights of that particular neural network are updated. We have seen that in a neural network that is used for reinforcement learning, we input the state or states, and as output we get a certain action if it is a deterministic policy, or we get a probability distribution of actions if it is a stochastic policy. So yeah, this is the basic working of a neural network in reinforcement learning. In the next lecture we are actually going to see the policy gradient equation, and it is going to make a lot of sense for you now that you have understood that how neural network works in reinforcement learning. Thank you.